So we're still on 5.5. One more time, I'm just going to remind you one more time. Can you make sure you write the angle in there? I know when you're doing your homework, sometimes people go, well, I just want to write sine, but not write the angle. You have to write the angle, because next year I give you double angles and stuff, and there's half angle, so it'll be 2 theta. Or half theta, stuff like that. So you can't just assume that sine always has an angle of theta, like a single angle. You have to get used to it. I was looking at my grade 12s who wrote their evaluation today, and some of them are still missing their angles, right? And it becomes a habit, right? Like it's a muscle memory. So please, please write the theta or the beta or whatever I give you beside it, right? Otherwise, it's muscle memory, and you're going to forget on an evaluation, right? And so you don't want to do that. So let's do left side, right side. So the first step here is to separate the left side and the right side. So now we're going to grab the left side. So I think I'll just grab the left side here and go left side. Make sure you work on the left side of the page, not right in the middle, because we're going to have to do more work, right? So left side. I want you to write down the question like a title. When you're writing it down, you're also analyzing it. So as I wrote that down, I went, okay, I have my left side. You don't have to highlight it, but I'm just showing you I have to grab the left side from the original question. Don't change anything. Keep it exactly like that. Then you're going to say, when I wrote that down, I noticed that there was a secant. And secant is one of the reciprocal identities, and we don't really like the reciprocal identities. We end up just changing them back to the regular primary identities, primary trig ratios. Okay, so we end up, I'm going to change that one to, what's secant? Secant is actually 1 over cos, right? So we're going to change that. So we're going to do that. When I write down my right side, so I'm going to grab my right side over here. I'll move it over. I don't know how far I need to, but I'll just do right side equals. And cos theta. So please write the angle. Okay, and I know it's a pain in the neck to write it, but like I said, next year we're going to have double angles and stuff. So not writing is really going to be extra wrong. So theta minus cos squared theta, and 1 minus sine squared theta. So one more time, I need you to write the original question. You don't have to highlight it, but I do want you to write the original question as part of your introduction. So this is your title. I do want you to break it up into 2 parts and not keep it together. By keeping it equals in the middle, it means that the left side equals the right side. That's what it's saying. By breaking it apart, it's saying that I'm proving that this side equals this independently of each other. Right? So you could still be doing it the same along the middle, but having the equal in the middle already indicates that it equals each other. It's making an equation. So I want you to take my equation, break it up, and prove left side equals right side separately from each other. I still want you to look, though. You're looking at each side, so it's giving you the hint. It's giving you the clue of what to do, but keep it separate. That's part of the process. So I want this part done here properly, right? So break it apart. Then what you're going to do is you're going to grab this left side and the right side and see which one you want to work with. Now, this secant right away, if I look at the right side, it's all coses and sines. I don't want any reciprocal identities, so I'm definitely going to change that to cos. So right away, I'm going to change that to 1 over cos. I'm going to keep this separate, 1 minus cos theta. Okay, and then now compare. And you go, okay, so this one and this one, they're supposed to be the same. This side has a bracket. This side does not. So how about we do distributive property to get rid of the bracket? You want it, or you can get a bracket out of this one, up to you, but I'm going to do distributive. Let's get rid of the bracket. When you get rid of the bracket, you have to remember your fraction rules and stuff. So whenever I have a fraction mixed with whole numbers, I used to tell my grade 9s, put it over 1. Put it over 1. Then you know you're doing numerator times numerator, denominator times denominator like that. Put it over 1 so you can see what's happening. Okay, that's a good habit to do. 1 times 1 would get me 1 over. Denominator times denominator is cos theta. Okay. Then for the second one, numerator times numerator would be minus cos theta. Denominator times denominator gets me cos theta. Are you getting used to it like algebra? Right? Some of the homework was to just work with the algebra, right? Part of the homework was simplify this, and they were asking you to do a bit of simplification. Okay, I'm going to stop there. Oh, no, I'm not going to stop there because look at this. How are they different? This one has all over, right? This one has 2 bits. So I would like this to be all over, the same as this one. So you're trying to match them. That's why it's nice having the two sides. So I'm going to do this. I'm going to go 1 minus cos theta all over cos theta. Okay, that's not bad. That's not bad. Right? So now it's both got denominators all over. That I'm kind of stuck with. So I'm going to go to the right side now and see what else I can do there. Now remember, this is the same thing as anything with algebra. So what you're picturing is when I see this, I'm actually picturing y minus y squared over 1 minus x squared. What can I do with this top part here? Knowing all the little rules we did last day. You can simplify, you can collect like terms, you can factor, you can expand, you can, what do we say, substitute. What do you want to do with that? What would that be shouting out to do? That was just regular letters. Yeah. Common factor, right? So it's a common factor. How about this on the bottom? 1 minus x squared. Yeah.
Can't you change 1 minus sine squared? Can you change that to
Yes,
cos?
exactly. So this one should be shouting at you going, but wait, that is cos squared. The Pythagorean identity that I want you to memorize is sine squared theta plus cos squared theta equals 1. And every variation of that. And again, that is like this. A squared plus b squared equals c squared. You automatically always go, but I know that b squared is c squared minus a squared, yes? Like you know how to do that in your head. So if I ask you for side b, if I said a squared, what would it be? C squared minus b squared. So all those variations of Pythagorean identity, Pythagorean theorem is the same as what you're doing here. So first of all, yes, I want to do a common factor on the top. Here I could do a difference of squares, but look at the denominator here. I don't want sine down there. So it's giving you a hint. It's saying, you know what? I don't want sine in my life at all. I wish that was cos. And we do know we can switch it. So I'm going to do two things. I'm going to common factor. So here, common factor is my thought for the top. And here, change to cos. You're only allowed to change it to cos if cos squared, if it's squared, right? Remember this Pythagorean identity, this only works for squareds, yes? Right? So this only works for squareds. Any combination of twos, but not for singles, right? So it doesn't work for a single, it has to be squared. So I'm going to common factor this guy out first. It'll be 1 minus cos theta. Oh, that looks promising. Look, promising right there. That is a good thing. You can keep looking. I want you to cheat. Sorry, it's not cheating. I want you to sneak a peek. Sneak a peek at the other side, right? It's there for a reason. You go, oh, that is lovely. The denominator, I go, wait, oh, I do not want to do a difference of squares. People go factor, factor. No, no, no. You're planning, you're plotting, plot. I don't want sines. I wish it was cos. So this is actually cos squared. Right? And that's exactly what I was going to do, right? Because people say, I do factor on the top, you go factor on the bottom. Don't blindly factor. I want you to go factor on the top, but factoring the bottom doesn't help me. I simply don't want sine down there. I wish you were sine, cos, and I can switch it. Now, what can I do? Knowing that these are just like variables. Yeah. Yeah, get rid of one of them and one of them here. And rewrite it. And look at that. And don't tell me this isn't satisfying. This is super satisfying when you go done, right? I want you to write a conclusion. Your conclusion is therefore left side equals right side. It actually, in the olden days, we used to not put left side equals right side. We would put something called QED. And it was Latin from quod erat demonstratum, that which was to be demonstrated. It was very satisfying because we'd be like, QED, QED, but no one ever says that anymore because Latin is no longer a language. Anyway, but QED, so it's a Latin. So you'll see some old books. Also what we would do is we would put a square. We'd call it the tombstone, and it would say done. So which was to be proven is done, and they put a square. Some books would put a solid square, but but teachers were picky with like how you colored it because it would like make sure it's solid. Anyway, so those are all ways to end a proof. Left side equals right side is good, but QED. It used to be very satisfying, but still, left side equals right side is very satisfying. So that's what you're aiming for, is that you want to get them to match. When they match exactly, you stop. So sometimes you have to do the right side like 4 or 5 steps. Sometimes the left side, none. Sometimes you work on both sides. There's no telling. Yeah. In your homework, yeah, so good question. Will there be a time when left side does not equal right side? In your homework, there are some questions that say, prove if possible. Those are super fun because sometimes you go around in a circle for days, and I'm just kidding. They're not fun at all. They're actually mean and little bit evil, but will we do that? No. On your evaluation, we will give you ones that prove. It is fun to say, ha, it didn't work, but I won't do that to you because it's only fun for me, apparently. But yeah, so on the evaluation, good question, we will make sure all of them prove. Left side should equal right side. In your homework, though, there's a question where it says prove if possible, and on purpose, I think they gave 1 or 2 that didn't work. Do you know how you check if it doesn't work? If you're like, I think I'm crazy, but I think this doesn't work, just put in an angle. Tan of 30, does it equal 1 plus tan 30 plus cotangent of 30? And plug it into your calculator. And if left side doesn't equal right, you're like, oh, this is the one that doesn't work. To prove it doesn't work, you just have to put in one number. And then you go, this thing doesn't work. Okay, but yeah, so the ones on the evaluation will work. Okay, I'll triple check them. Because one time I had a typo, and that was really disappointing for everyone. Because you're like, what? It doesn't work. Yeah, but we will triple check it. Okay, here we go. Let's try it again. Okay, so let's get with the strategy. We're just going to kind of get really comfortable with the strategy. So first step is just grab the left side. As I write it, I kind of analyze it, tan, okay. And then I'm going to grab my right side, and I'm going to go 1 plus tan. Okay, there's 2 ways to do this one. So when I was writing it, I'm like, okay, I've got tans and cotangents. I can switch everything to sine over cos, right? I can do sine over cos, sine over cos, sine over cos. Or I can switch cotangent to 1 over tan and do it that way. So you actually have 2 different ways to do it. Which way would you kind of feel? Tan? Yeah, switch this one to cotangent to 1 over tan. Is that okay? And let's switch everything to tan. Okay, and if you don't feel that way, you can do sine over cos. It'll work both ways. The sine over cos way only adds like maybe 1 more step to it. It's not bad. Okay, so let's make cotangent 1 over tan. Is that all right? Okay, so now we're going to try a fraction question. So this is something over something. This is going to be the same strategy we're going to do a lot, and it's going to be lowest common denominator. So I'm going to grab this part here, and I'm going to say 1 plus tan theta. Okay. I don't like writing fractions on a fraction. It just feels messy to me. So I write it horizontally. So I'm going to do this. I'm going to grab this guy. Oops. I'm going to make it orange, I think, here. Okay. Put that in a bracket. And I'm going to go divided by, and then I'm going to bracket the denominator as well. Okay. And I'm going to go 1 plus, and cotangent is 1 over tan. Like that. Okay. I'm going to highlight this. You have to put all of the numerator here in a bracket, and you have to put all of the denominator here in its own bracket. Does that make sense? Because otherwise it's 2 terms divided by 2 terms, and if you don't put the bracket, then look, it's only tan divided by 1. Okay, so I need you to bracket the whole top, the numerator, and the whole denominator. If you don't put the brackets, it means something else. It just means that tan was divided by 1, right? And that's not what you mean. You mean all of the numerator is divided by all of the denominator. Okay, so you have to, I'm just going to star that. If you write it wrong, you're losing marks right there. Okay, so don't just grab all the top. And then you can write it horizontally. So then, when I do this, I want it to be lowest common denominator. So like this, and we're going to go tan theta, like that. Okay, so we're going to go equals 1 plus tan theta divided by, and now look, tan plus 1, so I'm going to go tan theta plus 1. I'm just doing lowest common over tan. Do you remember doing this in chapter 2? Okay, so that plus 1 all over tan. All right. So once you get it all over, we like this lowest common denominator. Okay, and this is going to be the same thing. We do this a few times. Division is going to become multiplication. Are we okay with that? So it's going to become multiplication, multiplication, and then we take the reciprocal of this side. So this will be tan theta over tan theta plus 1, like that. Right? So make it multiplication and then reciprocal. Is that okay? You don't have to show the arrows, but I'm showing you what I did. Multiplication, then reciprocal. Okay, we're almost there. We're so close. Keep comparing to what we want. What we want, what we're hoping to get to is just a plain tan. Can you see it? What can we cross off? This is over 1. Remember, whenever I have a fraction mixed up with the whole number, I put it over 1. Are we allowed to cancel out this binomial with this binomial? Yes. The full binomial, are they the same? 1 plus tan and tan plus 1? They're the same. So I'm allowed to cross off a whole binomial with a whole binomial. Never a monomial with a binomial, just binomial with binomial. And then you write what's left over, which is, in fact, tan, and therefore left side equals right side, or QED, or square box, known as the tombstone. Yes?
Are you allowed to expand it first and then cross off after?
Expand it this way? So expand it.
Like you do the multiplication and then cross it off after?
Yes. Yep. So put it all over 1. Yep. So you would keep it. Would you keep it as 2 as a bracket? So you would go tan theta 1 plus tan theta, like this.
Yeah.
Yep. So put it together and then cross off. Yep. For sure. Yep. So you can put it all over 1 and then cross off. Good. Okay, super satisfying when you get it to equal. You're going to be like, it's so close, it's so close. So you're trying to match it. Okay, try another one. Any questions with that? Anything else?